Look at that.
Hi, Chris.
See that applause? That just shows the love that gives him a good feeling. Now we're ready to go. Why don't you have a seat?
Yes.
Matthias, feel free. So, tell me, first of all, before we get into the whole presentation, how do you feel today?
Feeling great, yeah. Really looking forward.
All right. So maybe you could tell us, what does the autonomous factory actually look like?
So first of all, the autonomous factory is our vision of a smart and self-organizing production of the future. Even more in the future, it will be highly flexible, resilient, and sustainable. And I know this is a bit abstract, so I suggest let's make it more concrete, let's make it more tangible, and let's watch a short video together. I invite you to have a look into the future, maybe 15 years, 20 years, nobody knows.
All right.
So let's watch this short video, and I comment a bit on it. So you see this little girl, Zoe, who builds a toy robot just based on her imagination. Wouldn't it be great if she could order this small self-designed robot as a real toy, but just a fingertip? The whole supply chain will be highly interconnected and deliver the material needed to do the job. In the autonomous factory, the material receiving area will be highly automated. You see these autonomous forklifts running around and unloading material and load carriers from the truck. To do this, different AI technologies will be needed, like detection of the pallets or the load carriers and the generation of the workflows. These intelligent systems will be equipped with advanced safety functionalities to make human-machine interaction safe and reliable in the autonomous factory. In the autonomous production, while this little girl Zoe is waiting for the robot to be produced, different production units group into flexible production setups and collaborate to solve the task to produce in the end parts of the robot. To do this, they have to exchange information, like the perception of their environment, for example. But not every task can be solved by single machines, but there will be an overall production orchestration, which must be highly optimized. So the different tasks are broken down into subtasks that can then be assigned to single machines that have the adequate skills. The whole optimization of intra-plant logistics and production will happen automatically. Almost every part can be assembled by these intelligent machines, but all the intelligent systems, the AI systems in there, they could also reach certain limits. Just imagine an AI model is not confident about a certain prediction. It must be able to ask for help. And the human operator will, in the end, provide feedback to let the system learn and improve continuously.
So that's an interesting feedback loop between, once again, the artificial intelligence and human intelligence.
Absolutely.
So tell us, where does technology, or where do certain technologies like AI support humans in the autonomous factory?
Yeah, that's a really important point for me. It's close to my heart, to be honest. So this is really about the autonomous factory designed by and for people. So it's not about replacing human workers in the factory. It's about assisting them, making them more efficient, making applications less error-prone wherever possible. It's also about automating repetitive tasks that might be inconvenient or unsafe for the workers. And maybe an automation system can do it better and faster and more efficient and also economically scalable. So it's all about human intelligence on the one hand side. Human is unbeatable in terms of creativity or problem-solving skills in unforeseen situations, and artificial intelligence, super fast computation, intelligent algorithms, perception, interpretation of data. So these are two things on their own. They are already strong, but if we get the interplay going, this is unbeatable, and this will be the next level of automation.
So maybe you can tell us, where can we already experience AI, for example, being implemented in industry?
Yeah. So AI in industrial production is extremely versatile, and it also finds its way to the automotive industry. Did you know that in the car body production, where you have to join metal sheets, there are 5,000 weld spots usually made during these production.
I didn't know that.
5,000 weld spots. That's done by these robots that you see in the back. That's a crazy number, right? How could you ever inspect 5,000 weld spots if they are done well, or if there is a defect or something like that, or a weld splash that you have to remove? Impossible, right? So, and today this is done by sample inspection. So just a small portion is really inspected. And that's actually the challenge. A German automotive producer came to us and told us, okay, there's a big challenge. Can you help me to solve it? And that's what we did. So we implemented machine learning models that are able to inspect during production, during the welding process already, if these weld spots will be good or if there will be a defect or a weld splash, for example. And this leads in the end to 100% test coverage. So 100% test coverage, this means no sample inspection anymore, but you can assign a quality score to every single weld spot of the whole car body. And we were able to improve the defect detection rate by 17%. So really significant number, 17%.
That's amazing.
That's big customer value.
And that's also for the customer. I mean, for the end customer, it also gives them a better feeling, right?
Absolutely. And there's more. Did you know that AI also makes a contribution to sustainability aspects? One of the hottest topics around,
I can
right?
imagine.
So we have one nice use case here. This comes from China, where a Chinese customer approached us. And maybe you know what these silver bars here in the back are. These are the raw products of solar panels, or also semiconductors are built from these kind of so-called monocrystalline silicon ingots. So these are huge bars, several meters long, of silicon. And the production process of these ingots is extremely complex. You have a big pot, a melting pot of liquid silicon, several hundreds of liters, and you have to control the temperature, for example. And you get very late feedback. If you change a parameter value, you cannot really tell if this is now a good effect or if the whole system still works or not. So super difficult to control. And with this challenge, the customer approached us and asked, could you help us with AI? And we said, we don't know, but we will try. And we tried in a lab environment first, and it was so significant in terms of results that we rolled it out to many furnaces in the factories in northern China. Let's have a look at the numbers. And in my opinion, these are really outstanding. So we have 8% increased production speed. So throughput of production was significantly improved. And even more outstanding, in my opinion, are the quality KPIs. We were able to improve the quality of production by 65 or even 78%, depending on the KPI that you take into account. So it's about the flat surface of these ingots, for example, that are pulled out of the silicon, or you don't want to have structural losses of this silicon, for example. So tremendous results using AI in this quite complex environment. And that's what I'm talking about. Everybody now talks about AI for predictive maintenance, anomaly detection, visual quality inspection. So these are the low-hanging fruit use cases, and we should tackle those. That's a good idea to go step by step. But where there's a huge potential still in terms of AI for optimization of production processes. And that's one example that we achieved there.
Okay. Now, I can imagine that there are still some challenges, though, until we see AI being suited for broader applications.
Yeah.
What are these challenges?
Yeah. So first of all, AI in industry is quite different from AI in the consumer world. And
right,
you see
because
that
I can imagine in the consumer world, we're already using it basically on a daily basis. We don't even
exactly.
notice it, right?
Exactly. Yeah. So that's a big difference. So if you have a look at this infinity loop that you see behind me, this is kind of DevOps for AI, if you like, machine learning operations, we call that. So it's about building the AI model and operating the AI model in the end. And if you have a look at the different phases there, in every phase there's a challenge. So let's go through it step by step. So first of all, you have to clearly define the requirements for your AI model. You have to specify what do you want to achieve? What are success factors? What are the KPIs? And how is the problem solved today? So you kind of have a benchmark for your AI model. Then it's all about training your AI model. You need high quality data to get a high quality AI model. So easy is that. So it's about connectivity. It's about using virtual data coming from simulations, for example, and bringing this virtual data together with the real world data, augmenting your data is the keyword here. So to really make high quality AI models. Then it's about testing, validating your AI models professionally. In the future, maybe even certifying AI models. If you have critical applications, safety critical, for example, you have to certify those. Then you're going to deploy your AI model into the real world, onto some edge device, for example. The inferencing happens. And now it boils down to the point, can you really make the step from proof of concept to AI operations, right? Because it's about scaling your AI models to different machines, not only having it running in one machine. That's not what you want. You want to roll it out to many machines, to many factories. It's about scalability, generalizability, transferability. That's the holy grail of AI, and everybody works on this.
And so you actually reach the point that you have an autonomous factory. So how do we, move towards or what does it take to move towards the autonomous factory?
Yeah. What's really important as a first step is, and this is what Siemens is working on. So we are tackling all these challenges that I just mentioned. We are going to make AI industrial grade. This means robust, reliable, and trustworthy. And that's the first step. You really need to be able to trust your AI model. And then it's in the end a step-by-step approach, right? So this is a big vision, we are aware, and it's still a way to go. I did say 15, 20 years, maybe it's something like that. So it's about industrial AI, it's also about flexible production control, it's about intralogistics, advanced safety. There are so many aspects and puzzle pieces that you have to solve to get it going. So it's an evolutionary journey, if you like. We really have to go step by step. And for every customer, there might be another focus topic maybe. So one customer really wants to focus on production control, another one on material handling, right? So my suggestion, really get going today. Now's the time to start with digital transformation, and we really have to do it together. This word ecosystem is stressed a lot nowadays, I know. But I really believe in the space of industrial AI, this will be even more important than ever before to join forces. This is such a broad field, it's super complex, so many specific requirements and use cases, nobody can do it alone.
Right.
We are doing that with our partners, our customers, research institutes, startups, and so on. So my invitation, please join us on this journey towards an autonomous factory. Reach out, let's make the first steps together.